Okay, so in the last video, we created a macro to shorten. Instead of writing these two lines, we will be just using this define for all cells for any two-dimensional vector which takes any data type in, which is why we declared it as a template class. Okay, again, so it is because it can take any type of 2D vector, any type. By that I mean either a double or an integer or a string or a char or a class vector, anything like that. But we have got to define one more macro, because when we define for all from I0, from row 0 to size of the mesh, and from J0 to size of the mesh here, we are including this black dots, which is the boundary elements as well. And most of the operations that we will do, it will be separate for the internal yellow zone. So it's good to define another macro which will just be specific for the internal elements. Okay, so all we need to do is just replicate this thing instead. So we will copy this, and without leaving another line, no empty lines here, and we will say for all internal, and we will say if this is the case, this will be starting from 1 and this will be -1 and -1 here. So now this has been done, so we can use two macros for all cells and for all internal cells. Right, now it's time that we start creating the mesh first. So before we move on to anything else, let's just in src, let's make a new virtual folder which is called mesh. Mesh, and in this folder, let's say we want a new class which will be called also mesh. Okay, so now we have created a new class called mesh, and let's walk in. The first thing we will do is we will include the for all operations that has the macros that we defined. And now we have to create some variables which will be let's make these variables private. So it will be double xs, ys, xe, ye, xl, and yl. So what this is xs is the start position, ys is the start position in y, xs in x, and now you can guess xe is the end position and ye is the end position for y, and xl is the length and yl is the length in y. So if we just create this some kind of, like, let's say this is node and another node, and we create, so if we make a grid like this or something, this will be xe, uh, xe, yeah, and this will be xs, and this bottom line will also be ys, and this top line will be ye, and the length difference between this node and this node will be yl, and this node will be XL. Sorry, this node and this node will be XL. So this will be XL, and from here to here will be YL. Okay, so moving on, we have declared some variables for the start and end position and length of the domain. Now we need to create some uh, integer variables, which will be number of elements in x direction and number of elements in y direction, and also a double, which will be the spacing dx and spacing dy. So it will be the grid spacing in x direction and grid spacing in y direction. Okay, so now we have to define some of the something called type def. So it's obvious from its name, we are defining a new type that has not been yet declared in, I don't know, C++, we can say. So now you know what is a vector of integer. And I'm going to say that instead of writing this whole thing vector of integer, whenever I want a vector of integer, I will type single int field. Okay, so that's the abbreviation that I'm going to use for this type of data, a vector that takes an integer. Now I'm going to create similarly for vector of double, we'll call it single d field, single double field. Single because it's one dimensional. You can name it whatever you like, but I would want you to keep it consistent with me so that you don't get confused. Now I'm going to create a two-dimensional vector, which will be a vector of a vector taking the data type integer in, and we have to close this data type, and it will be 2D int field. And similarly for double, it will be a vector of vector that takes the data type double, and it will be called 2D double field, right? Okay, so there we go. We have declared new types, which will be for vector of integers, vector of doubles, vector of integers, and vector of doubles. So this is a two, these two are two-dimensional. Okay, now we have uh, got to create some functions first. So the first one, because even though we have a two-dimensional vector, we need to calculate the position of x for every node and the position of y for every node. So x and y positions in this vector. So it will be, I will call this function calc x, and it will be taking obviously 2D 2D double field, and I will use this and sign to make it, to say that the whatever input that we give here, the vector will be taken by reference. I'll come to discuss what is taking data by reference later. Okay, so we need to declare a similar function for calc y, and also it will take similar type of data, and we need to declare uh, assign node type, which will take 2D int field as well, and void assign node boundary type, or let's make it short, assign boundary type, and this will also take an integer. And last function will be create mesh, and it will be taking an object mesh into this. Okay, so before we go ahead and discuss this, you will understand this in a bit. First, I want to create some constructor definitions. Okay, so now you know that this is the default constructor. We also need an overloaded constructor. So in overloaded constructor, we will take, basically what I want to do is let the user decide what is xs, what is ys, what is xe, what is ye, and how many elements in nx and ny. But in order to do that, I need to say that this constructor will take a double, a double, a double, a double, an integer, and an integer for this particular constructor. Okay, and there we go. So now let's move on to the CPP file where this particular one is, we know already, is the default constructor which is being called from here. So this is the default constructor, and now we need to create one for the overloaded constructor, and it will be mesh. Now notice that when I do that it comes with the definitions here. So now I can actually I can define these what so I said here it's a double 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 double, so four doubles and two integers. So it will be double. Instead of writing xs, I will write here new xs, and this will be new ys, and this will be new sorry, I have to say double, new xe and new ye. And that's not done yet. We need new nx and new nx and integer new ny. So now the user can input these 6 variables in this constructor when they are calling uh, the class mesh. But we also need to, because we have some private variables here, which is xs, ys, xey, and xl and yl. So uh, we want to initialize the private variables by uh, the user input. So let me just write this curly brackets, and then when I write this sign, it means initialize. So I will initialize this nx that we declared here. These are public, but nevertheless, and these private variables here. So nx will be initialized to new nx, and y will be initialized to new ny, and xs, I guess I called it. Let me just, yeah, xs will be initialized to new xs, and so on. So let me just quickly type that. And there we go. That's the 6 variables are now initialized to the data input by the user. And now it's time for us to create some vectors. So since we defined some data types here, we can actually declare that there will be some vectors for that particular function. Okay, so the first vector that we are going to define is mesh, and it will be a 2D double field because x and y positions should have double values. Okay, so to mesh 2D double field, and it will call this vec x. And similarly, 2D double field vec y, and mesh 2D int field, and this will be vector of the node types, and mesh 2D will be vec of bound vec node boundary type. Okay, so let me just write some comments here so that we know what to do. So this vector of node types, we can declare like the outer boundary to be boundary and the internal to be a fluid zone. So we will say if we assign number 1, it will be the internal fluid zone, and number 2 will be for boundary. And vector of boundary type, number 1 will be for wall, number 2 for inlet, and number 3 for outlet. Now in this particular lead driven cavity case, we don't have all this stuff outlet, we just have an inlet and some walls. Okay, so now I have declared 4 vectors: vector of x, vector of y, vector of node type, and vector of the node boundary type. Right, now we can initialize these as well. So in order to initialize, we must come back to this overloaded constructor and say that um, the vec x will be initialized to the size of nx and also to the size of in y direction ny and initialize to value of 0.0. So we just initialize into 0, and let me just go to a new line and say vec y should be initialized to um, nx and my bad, because I actually forgot to initialize these xl and yl. So xl will be initialized to xl will be initialized to xe minus xs, and let me see if it is called xl. This is what it is. So xl will be length x end minus x start, and yl will be y end minus y start. Right, now we can't initialize this vector to nx, rather we need to initialize this to what was given by the user. So it will be new nx and new ny, and we will copy this and paste it here to make things a bit faster, and just rename this as vec y. And also we have 2 more vectors coming, so I'll just paste this 2 more times. Wait a second, I missed some brackets there, so I need to close this bracket, and 2 more times and 1 more time. That's going out of bounds, so I'll go to a new line, and yeah, so I close this, and now this is vec x, vec y, and now I need vec node type and vec node boundary type, but I wrote one extra, so I'm going to delete that. Now the only difference is that x vector will be taking the data type double, y vector will be taking the data type double, but this vector will be taking the data type int, and this will be taking the data type int as well. Okay, so there we go. We have now declared this we have now initialized all the members from the data that user input in the overloaded constructor. Okay, so now if I say that because we need the spacing, I'll say that dx will be the length in x divided by the number of elements in x minus 1, and the length in y will be of course yl divided by ny minus 1. Now it's quite simple, and now it's time for us to define the functions that we have written. So these four functions I'm going to copy in here and paste it here, and then I'm going to say give some curly brackets for all of them. I need to delete this guy. Okay, so this vector here, now to calculate x, it will be for uh, unsigned integer I equals 0 to I is less than, and here I have just declared the data type. I need to give a name here, so it will be, I'm going to call it vec, and from I equals 0 to I is equal to the size of this vector, and because it's two-dimensional, for j equals 0 to j is less than vec I dot size and j plus plus. Now we can do something. So this is the definition here, but since uh, I is rows, so I guess I should first explain. So I is the number of rows, so x will be changing from here. Let's say if we start from 0, from here 0 0.1, 0 0.2, 0 0.3, 0 0.4, something like that, and y will be from here. So for example 0, 0 0.1, 0 0.2, 0 0.3. So if you think about it, change in x is happening when we iterate through j, and change in y is happening when we iterate through number of rows. So so in order to define x correctly, we need to start from j is equal to 1. So we will be, because the position, uh, let's say I will write here vec at any row and the 0th column will be equal to xs, the start position, and after that vec at any I and j will be equal to vec at I and of course j minus 1 plus dx. And we can do a similar thing for the y vector as well. Just copy and paste, but this time it will be such that here instead of I we will swap places and we'll say that the 0th row and the jth column, all j columns will be equal to ys, and vector at I and j, so this time I need to keep I1 and j 0 because we are going to start from the first row and iterate through that. So vector will be I minus 1 and j plus the spacing in y direction. Okay, so that will define for us an x vector and an y vector. Right, so now we can define the node type. So here instead of writing all that stuff, I'm going to write for all cells that we defined in this for all operations file, and I will say vec. So here also I guess I should write vec, and here also I should write vec and some curly brackets and say vec ij is equal to 1. So initially we are saying all cells node type is fluid. After that we say if j is equal to 0, so if it is the 0th column, then vec ij is equal to 2. So this will be a wall or a boundary, not fluid zone. And similarly, if uh, I is equal to vec size minus 1. So at the other end, it will be also a wall. So all basically all the all the first rows, all the last row, and the first column and the last column will be a wall. So is equal to 2, and we'll just copy this 4 times and say that if j is equal to x size minus 1, also it will be a wall, and if I is equal to 0, also it will be a wall or a boundary. Let's say boundary. Okay, so when I print these vectors out, you will have a better understanding of what I'm talking about. Since we are not making grid by another software or something, we have to do it kind of this way. But if we have defined boundaries and everything in another software, then we could just read the grid and just assign to this vector where the boundaries and everything is. Okay, so now we have defined that uh, all the outer edges are boundaries and all the inner ones are fluid, right? Moving on, now we need to assign, since we said that there will be 4 boundary is walls. So here also I guess I should declare here this function. I made a little mistake. It will take some vector by reference and also another vector by reference. So in field, and so 2 vectors it takes, and here it will be, let's call this vector vector I, and to the int field and vec b. Okay, so for all vec I, if vec at I and j, sorry, if vec I and j is equal to 2, so if it is a boundary, then do this. Okay, so first of all, if j is equal to 0, then vec b boundary vector ij is equal to 1. So let's see what vec b here we said. 1 is for wall and 2 is for inlet. Okay, now that's a wall. So this is a wall. It's actually the left wall, I guess. Okay, moving on. If I is equal to vec b dot size minus 1, then it's also a wall. So there'll be 3 walls and only 1 inlet at the top. So this is also a wall. Okay, so 2 more to write. Let's just copy this and paste here. And if I is equal to 0, then it's also a wall. But if j is equal to, then it is inlet. So this will be inlet. Okay, so this is everything that we need to do for assigning some values to the vectors that we have declared. Now we need to write our last function. So it's this function that we create mesh, and it will be, so void mesh create mesh, and it takes mesh class object. So I'll call this mesh and by reference, and I will say create calc. So I'm calling these functions inside this. Uh, so it takes vec x in mesh.calc y takes vec y in, and mesh.assign node type first will take vec node type in that we declared here and we initialized here. So and mesh.assign boundary type will take vec node type and vec node boundary type, two vectors. And let's, if this function was successful, let's just see out to the screen that successfully created mesh x, y, and boundary types. Okay, so now it's time for us to actually call this class in the main function and see if everything worked out fine. Okay, so it can all be very confusing unless we actually see on the screen what's going on. All right. Okay, so first of all, let me actually say that I'm going to create some variables that the user can modify. So ye and integers nx and ny, and I'm going to say that xs is 0, 0.0, ys is 0, 0.0, xe is 1.0, xye is also 1.0, and nx is 10, and ny is 10. Now, first thing I need to do is include this new class that I have defined. So I include mesh.h so that I can call this class now. So mesh, and I call I create an object. So when this class is mesh, and I'm going to create an object of this class called mesh with this underscore sign. So it's just I guess a regular style of C++ programming to make it like look like this. You can call it anything, so it can be mesh to blah blah blah, but I'm just going to call it mesh. And I'm going to say I'm going to call, so now you see that there's one of two because we have two ways to call this mesh class. One is through the default constructor and the other is through the overloaded constructor. So I'm going to call this from the overloaded constructor, and I'm going to say that it will take these variables that I have just declared on the screen in main file, so nx and ny. Okay, so there we go. So if I now there might be some errors that yeah, because I created this as new nx typos and stuff, so some stuff there. Let me again see what other errors I have. So I'm doing like a real-time compilation where all right, because I deleted the iStudio, I'm gonna see out that and see if it works now. I have calcex. One second. Right, so I have forgotten to say that these functions are coming from the class mesh. So, and here also mesh and mesh and mesh. Let's see what other errors we have. Um, okay, I forgot to delete this semicolon as well. And here I have forgotten. I'm being very sloppy. Where else? Let's see. Okay, so now it's gone through with some warnings. Forget the warnings because it's just about the ordering of data which you can. So basically, it means that if I declare here that nx and ny, after that dx and dy, then I should initialize here first nx, ny, then should come dx, then should come dy. But I'm not don't have the time to be very bothered about that. It's not going to give any errors. So now that it has compiled, we created an object of the class mesh, and we said in this function here that the spacing in x will be this particular one. So if I say cout mesh spacing in x, and if I say this object mesh dot dx, and let's see what we will get. So see if it worked fine or not. So spacing is correct now. In x is 0.11111. Okay, so now it's time to visualize the x vector, y vector, the node boundary type, and all that stuff. Okay, so in order to do that, I must first create. So if I go to create mesh, and because only in this function which is called create mesh, I have actually implemented this calc x, calc y, calc vector node type, and all this stuff. So I'm going to take this object, create take in this function, and take in the same object in which is uh, done there. So now if I say I'm just gonna copy some for loops from here, yeah, to make things a bit short. So close this, and change this to 0. And now if I say cout object name mesh.vec x at I and j for all rows and for all columns, and give empty space, some empty space, and end line after every row. Let's see what we will get now. Oh, I probably should write here mesh.vec. Actually, let's yeah, okay, fine. Mesh.vec x dot size, I think. Let's see if this will run or not. Oh, okay, so here I should write cout as well and compile again. Okay, so I think it worked fine. Let's compile and run. And this is our x vector, so it changes in j 0, 0 0.11, 0 0.22, and until our x length 1. And now if I change this to vec y, it should be the other way around, so it should be going down, and it makes sense. And now if I just node type and print this to the screen, so all the outer boundaries are the what you call the boundary, and the number ones are assigned for the fluid zone, so that worked as well. And next we will find the boundary type and run this project. And it is I guess I have made a mistake in, because this is a wall, this is a wall, and this should be a wall, and this should be the inlet. So let me just fix that. Okay, so there is a little problem in this assign boundary type vector. So what I want you to do is go to this mesh.h file, assign boundary type, and just delete the previous definition and just keep it like how I am keeping here. So 2D int field end. Okay, so if I go here and now I will say that for all cells and taking this vector, if I is equal to 0, so bottom row will be that vec I j is equal to I guess 2. Let me see. 1 is for wall, 2 is for inlet. Now if it is, this is a wall, and if it is size -1, then also a wall. And we will do for j now, and if is equal to 0, also a wall, but if j is equal to this, it is the inlet. So basically in C++, when you have for all uh, iterator and you are looping, first you loop through I, and for example here, first you loop through I and then you loop through j. So the in order to keep consistency, I'm just keeping j as the inlet, and I will explain to you why I'm keeping j is equal to nx as inlet later when we do the finite difference part. But for now, just set this j as the inlet, and let's just print this vector now and see what it looks like, if it is some problems or not. So this is a wall, and all these ones are a wall, and these are wall, and this particular guy here, number 2's, are the inlet. Okay, so that will be it for this video, and thank you.